have 40 seconds just to make sure we are on the same page. We have, as soon as the timer goes.
Mm-hmm.
As soon as the timer goes, you switch to scene to intro, and then once you stop it, then you switch to content. Hello everyone, and thanks for joining the AWS channel for another episode of Built on Serverless, but this time another episode from Australia, Melbourne, right?
Yes, absolutely.
Go ahead.
Welcome, everyone.
Thanks for joining, Steve.
Thank you very much, Heitor, for the invite. It's a pleasure to be here. So, like you said, we're in sunny Melbourne, and today what we're going to be doing is we're going to be looking at developing a .NET application using step functions and .NET Core.
And that's already open source, right?
It's absolutely open source. So
okay,
let me just quickly show you where you can actually find the end product for today's session. So this is available on our GitHub's sample site under AWS Step Functions Plagiarism Demo.NET Core. And all of the code that we're going to be doing over these next couple of sessions is available here. And what we're going to be doing is actually building this from scratch today. So,
woohoo! That's what we're looking for.
Absolutely.
Okay, so I will get the link right now, and I will send on the chat for everyone there.
Great, fantastic, thank you. So let's walk through a little bit about what this whole thing's going to be about. So this project is actually based on a real life application. It's not the exact one, but it's based on a real life application that I was involved in building for a university. And basically what the university was looking for was they wanted to have an application that tracked people's plagiarism violations.
Mm-hmm.
So for those of you who aren't familiar with what plagiarism is, it's basically referencing someone else's work without actually giving them credit for it. And universities have standards around this, and they wanted to make sure that anyone caught plagiarizing on a test or in an exam understood what the university standards were. So
Okay, so can you speak up a little bit? It sounds like the volume is low.
Okay.
Thanks for actually letting us know. How is it better now? Any better at all?
Good. Are we good?
Okay. So let me put this in the middle. Okay, let's carry on.
Okay.
A little better. So we need to project a little bit more.
Okay. I'll try.
Okay, microphone is closer now, so hopefully we're not shouting at your ears.
Okay, so where was I? So working through the process. So there was a whole workflow. So we built an application that basically we were going to register the incident for the student. Then we would have to schedule an exam. So the exam was to test to see what their understanding of the standards were. And the system would then send that student a notification that they had 1 week to complete that test. And then we had to wait to see whether or not they'd actually sat the test and what their score was. And so once we've determined whether or not that student had passed the exam, we would either resolve that incident or we would give them another go at sitting that exam if they'd failed. So all up, they had 3 attempts at passing that exam, and if they hadn't passed or sat that exam during for those 3 attempts, the university would take administrative action. Basically, they'd get suspended.
Okay. It's actually this is the polite way of saying, let's take some action on this.
Absolutely. So what we've
okay, you need to speak up. They're actually not necessarily hearing.
So what we're basically what this process spans over many weeks. So at a minimum of 3 weeks. And so we needed a way to be able to capture all of this information, capture the exam results, perform some business logic around whether or not what next steps to take. And so the application that we built, we did a lot of heavy plumbing in this application. And I thought today it's actually a good example of how we can simplify this whole implementation by using AWS step functions.
Awesome. Okay. For those of you who probably haven't heard about step functions is an AWS service that helps us to do any business workflow or any state machine look like. So think about when you have multiple functions or multiple processes that together do something or achieve a particular outcome. Step functions will show you visually how the representation of that workflow looks like. When it got executed, you also see green if activity worked, or you also see red if something went wrong. And each of those greens and red buttons, you would see what was the input and what was the output.
Absolutely. And today what we're going to do is build this entirely serverlessly. So we're going to use step functions to help coordinate all of the Lambda functions that we're going to be building and execute this workflow. So let me just show you a little bit further down the page here. The general architecture that we're going to be implementing today is this. So we've got just a sample front-end application which I've written in Vue.js, and that's really just a way to kickstart the workflow. Then we're going to build an API that's going to handle that request, and then we're going to pass the request from API gateway straight through to AWS step functions to kick off that workflow. So so that's one of the sort of, I guess, maybe the little known facts about API gateway is that it can actually integrate with many other services. It doesn't have to be just about Lambda. Mm-hmm. That's the partial architecture. Then the workflow, which we're going to be building today, is going to kick off. And then along the way, it's going to interact with some of the other services that we've got in this architecture diagram, like Amazon SNS for sending that student notification, and then DynamoDB to persist some of the results after that incident has been completed.
Okay, let me just stop you for a minute. I increased the volume a lot now. So can you let us know if you're actually seeing that now? Can you hear us better now? So I just had to increase the input to the maximum volume right now. So
much better, is it?
Ah, fantastic. Okay, all right.
All right.
Apologies for the audio issues. So if you need us to repeat, please ping a message on the chat. Happy to repeat very quickly. Do you need us to repeat? I'm happy to walk you through very quickly. No? Okay. All right.
Cool. All right. So let's quickly look at that web page.
Okay. Sorry. Can you go back to the sample code? Yeah. Mm-hmm. So sorry. Let me actually go quickly. Just summarize very quickly there. So the architecture that you're seeing right now is what we're gonna try to build at today. Essentially is the system, like we said, we're going to look at to see whether the student has cheated in one way or the other. And in the meantime, we need to validate the exam, and that takes a while. A Lambda function or a serverless compute perspective, it can now run over 5 minutes. And that's the reason why we're going to be using step functions to wait as a step out of the entire process. We can wait up to 365 days. Obviously, nobody wants you to wait 365 days. But the architecture that you're seeing is the high-level pieces. We're going to be using API Gateway that integrates directly with step functions. We don't have anything in the middle We make a REST API call, and then we will start an execution of the whole process. We have SNS to communicate between those microservices. We persist the data into a DynamoDB table. All of this is going to be traced by X-Ray. And we obviously are using the best front-end framework out there, Vue.js, to show how the system's gonna work from a front-end perspective.
I really like Vue.js.
Yeah.
Well.
So now that summarizes everything with the audio 100%. Apologies for the issue. Okay. Let's crack on.
Let's crack on. So where were we? Okay. So I was just quickly going to pull up this web application. This is just this is also in the project, so you can have a quick look at that. Oops, should probably open that up in a new page. Let's do that here. All right. So again, this is kind of just a simple one page application. What we're going to do is just we're going to enter a student ID, so whatever that might be, and when the incident took place. So that's going to kickstart the entire workflow, and then we're going to create a incident. And what we're going to see is that we've got a message here saying that the incident has been created, and we've got an execution ID, and this signifies the instance of that workflow that we've just kicked off. So we can then have a look at that. So let's do that. Let's click on this page, and here we go. We can see our application has kicked off.
Can we zoom that a little bit?
Yeah, sure.
Let's
maybe.
That's a
zoom.
fancy zoom. Look at that.
Look at that. There we go.
Okay.
All right.
Okay.
So maybe zoom this bit out a bit. Whoop. That's a fancy zoom. Okay.
Here we go.
So here we can see that all of these steps along the way have passed, and at some stage the student had failed, and now we have to take administrative action. So I'm going to just zoom back out here, just so we can see some of the individual steps. So what step functions allows you to do is that it allows you to interrogate the individual tasks that have been executed. Sorry, and we can see here's the data that started off the that execution flow, and we can see every task takes an input and generates some output, right? Mm-hmm. And here we can see, well, we should see some output here. Here we go. So here's the output for this particular task. So we've got some issues here. Apparently, looks a bit of a bug. We haven't been able to. We'll have to fix that.
It's a good thing. I actually like bugs because at least that's how I learn. Yeah. I like to break things and see if we can fix it.
Absolutely. So we've got a new incident ID. We've got the incident date. And yeah, we've got some of these other things, some of this other state data that we're going to persist. We've also sort of captured in an object. So we can go through here. You can even see errors that have occurred, and along the way you can see that we've captured some exams that they've set. So that first exam that they set, they only got a score of 39. The second one, they only got a score of 22. Again, they failed that exam, and the last one, they got a score of 48. So this student's not very good.
Well, I wouldn't blame the student. I mean, let's actually try to take a blameless approach.
All right. So yeah. So we can see also here that step functions also. It's a great way to be able to capture errors that have occurred along the way. We can see that there was an exception that's happened here. Looks like a DynamoDB persistence exception, and we'll address that on the. I think maybe we'll get to that in the next show.
Sure.
So let's maybe we should start building this.
So this is everything you should know to see how the end product looks like. I think it's fair to say that this is a big system. There's multiple Lambda functions out there. Everything's gonna be .NET based. So if we can get finished in the whole up to 2 hours length that we have, we're gonna be doing a part 2 because we don't want you to rush into things. We want to first make sure that you get the whole experience of how to build that in .NET using the tools you have available. And by the way, we have announcement, by the way, right? And secondly, we also want to make sure you can spend some time understanding the tracing, the handling exceptions and all those pieces.
Yeah.
So if we can get this done in this episode, we're going to be doing a second part.
Cool.
All right. So enough of the talk, right?
Let's get into it.
So I know you're going to have an announcement to make for .NET developers as well, right? I know you built something super cool.
Yeah. So I mean, just to before we jump into that, if you have a look at our website, if you go to AWS /Amazon.com/Visual Studio, just want to quickly show everyone where you can get the tools that integrate directly into Visual Studio. Now, I'm actually running on a Mac, and because we're doing .NET Core, I don't have Visual Studio running on machine, but we're going to be developing this application in a new cross-platform development environment called Rider from JetBrains. Cool. So we don't have any tools for Rider at the moment, but if that's something that is of interest to you, then please let us know. We will see what we can do about passing that on to the product team.
Right.
But so you can get all the tooling for Visual Studio right here. It's an extension into Visual Studio, and it'll provide you with a whole heap of tools that allow you to build Lambda functions, and give you some example project templates to be able to see how to interact with other AWS services like DynamoDB and S3 and quite a few others. So that's the tooling. Now, to make it easier a little bit for open source or cross-platform developers, what we've got is a cookie cutter. So this cookie cutter is based off the work Heitor did a little while ago. I kind of took this idea and we've now built this to help build .NET applications. So, Heitor, you built one for Python.
Yes, I did. Yes.
So, so we've got one here for .NET Core, and the way that we use this helps us integrate it into SAM Local. So let's have a quick look at SAM Local. Let's jump over here.
Yeah. By the way, SAM CLI, just in case.
Oh, sorry. Yeah.
No
SAM
problem.
CLI. Yeah.
No
Thank
problem.
you. Thank you for clarifying that. So we've got so we got SAM init, and let's just quickly take a look at the help files for SAM init. SAM init is a command that allows us to instantiate or initialize projects, and the little Easter egg inside this tooling is you can use SAM init to create serverless applications for any runtime that we support. Here's an example of how you would initialize a project for Python 3.6. But we've also given people the ability to create projects based on their own project templates, right?
Absolutely.
And here's where you can see how you, through this location parameter, you can see that all you need to do is actually pass it any kind of publicly accessible project file, right?
Yeah, not only that, you can pass anything that's a Git repository. That could also be private as long as your machine has credentials to access this. That could also be a zip file that's local to you or a folder that's local to you. Or that zip file could even have a password. The only thing that has to make you work is that the location that you pass, string, GitHub, Bitbucket, whatever that is, has to be a cookie cutter project, which is the open source project that's being used in order to bootstrap an application.
Yep, cool. Excuse me. So what we're going to do is we're actually going to use this cookie cutter. So cookie cutter is basically just a bit of a templating engine that allows you to substitute variables inside your project. It's open source. It's on GitHub, and there's more information available on the project directory. So
okay.
Let's have a look at how we would create our project for .NET. All right, so we're going to go SAM init / location, and we're going to just pass in here .NET. Cool. So what cookie cutter does, it's going to ask us if we want to re-download the template file. We're going to go yes. So the first thing we're going to do is give it a solution name. So what should we call this, Ada? So we should call it Twitch Plagiarism?
Yeah, I think that's a good name. I think the hardest piece for me, you can carry on, I can keep on talking.
Yeah.
The hardest piece for me is always come up with a name. A name is such a hard
I know.
time.
But because we're doing Twitch and we're doing plagiarism, let's just call the solution that.
Right.
And then it's going to ask us for a project name. So this is going to be the name of our first of our first Lambda function. So we're not going to start building this out now, but I'm just going to call this register incident because that's the stage that's going to help us kickstart this whole project.
Okay.
All right, got to spell properly, right? Register incident, and then the tool. This is a Twitch demo.
Okay.
Give it a project. Give the project a bit of a description, and then it's going to ask us, do we want to include API gateway? And we're going to go, yes, we're going to do that. And we're going to do some tracing. We're going to embed tracing in this project using AWS X-Ray. And then the question is, do we want to use safe deployments? Now, for now, we're not going to do that, but we can add that in later on. All right, success. And that's all we need to know to get this thing started. So let's have a look at the files that have been generated by this thing. So you can see here, I've got a solution file. I've got some projects. I've even got a test project. So we've initialized this solution with a test project that has all of the bits already hooked up. And you can start testing straight away.
Amazing. So what do you do next? Do you bring that to
so
Rider?
Yeah, exactly. So then all I'm going to do is open up Rider, and I'm going to go, right, file, open. I'm going to open my project and solution. Let's get rid of this guy. Oops.
Oh, you can do that later.
We do that later. Go to my Twitch folder, Twitch plagiarism, and I'm going to open up my solution here.
I'm not a .NET developer, so you're always going to see me. Okay, so the SLN is actually the solution.
Yeah.
That's why I need a solution name and the project name.
That's right.
Because the one when I built for Python, it was just give us the project name and we will bootstrap everything for you based on this. And I also saw some interesting. You have event.json, you have Cake for building stuff across platform.
Yeah,
you built all this already.
It's already part of the project. And we'll get into the build components in a little bit and why we need them. So you can see here I've got my register incident project, and it's already been initialized with a function, and that function has all of the dependencies it needs in order to get started. Now, as part of the SDK for .NET, we've got a couple of NuGet packages here that help us interact with AWS Lambda. So the .NET team for AWS has developed a bunch of stuff for us, and so yeah, including SDKs for AWS Lambda and our serverless applications. We've also got a reference here to X-Ray. So it's already pre-configured, and you can see here in the initializer in the constructor for our function that we're already registering X-Ray for all interactions with AWS services. So this is pretty much sort of boilerplate stuff, and you can customize that. And we might, if we have a chance, we can do that a little bit later.
Sure.
But this is a standard application. All it's doing, standard function, it's a sample implementation that's basically just getting the IP address, going to checkip.amazon.com and returning an IP address. And that's it. So, and the test project is already pre-configured. You can see that we've got some dependencies. We're using XUnit to do our unit testing, and we've also got dependencies on the test utilities that's part of the SDK as well. So we've got a way to abstract the Lambda context in our tests.
Amazing. So let me just recap very quickly I noticed some people just joined right now. So we just bootstrap a new application in .NET with now a new open source advanced template for SAM. So I just sent a command again on the chat. All you need to do is SAM init -- location, the URL I just sent on the chat. That gives us a solution for Visual Studio or Rider or anything in .NET, any ID that you want to use. We also got tests already done for you. Unit tests.
Absolutely.
We got X-ray already done for you as well for giving you distributed tracing and getting an idea about the performance impact of your Lambda function, the overall ecosystem, as well as any downstream as soon as you start bringing more services and more functionality into your functions. And we also got the build helpers, right?
Yeah.
Shout out to João. João is the guy who actually built the pull request to the SAM CLI project, and this is being incorporated now into this advanced one. So shout out to João for your contribution. Thank you so much for all the help.
Awesome.
You are really awesome. Thank you.
Thank you. The other parts, we've got a docs. We've got some solution folders here, Ada, that just have a README. Let's take a quick look at that. So that README has already got some information on how to interact with SAM CLI and how to build the project. So we've got some. So part of that project, we've got our template, of course. So this is our serverless application model template, and that template has our function defined. It has the specification, and this is what I'll explain to you in a minute. We've got our code URI. We've got a handler. So with .NET, we need to, when we're specifying a handler, we need to specify the full assembly, the class name, as well as the method that is being used to invoke the functions. So you can see here, this is the fully qualified, what do you call it? Name escapes me for a minute. Namespace for our function handler, and that's the entry point here. So you can see this sometimes confuses people in .NET. So we've got our name of our function, and here's our function handler, and that's what's going to be invoked when the Lambda function initializes or kicks off. So we've also got tracing enabled, and we've got a very sort of boilerplate standard event source for API. Now but I don't think we're going to need that.
No, because we're going to use API gateway straight to SAM functions, right?
Exactly.
So let's get rid of this for now.
Let's just get rid of that because we don't need that event because the event isn't going to be triggered. The step function is going to invoke our Lambda function, not API gateway.
Yeah, and we also need to remove the register incident URL in the outputs because there's no API being built. Otherwise, our CloudFormation is going to complain.
Yep, absolutely. So let's get rid of that.
Right.
So, but as you can see, we've got a load of stuff here ready to go without actually having to do anything, really.
One thing we forgot, we're actually, if you look at the template, global function runtime, we're now using the .NET Core 2.1.
Yeah, exactly. Good. I was just about to point that out. So
Nice.
this global section, as we start building more and more Lambda functions in our workflow, is got these are I guess configuration settings, properties for our Lambda functions that can be applied, as the name suggests, globally to all of our resource configurations. So we don't have to specify those properties for each and every Lambda function that we want to apply. So super handy, keeps this template really nice and small.
Right.
So let's take a look at some of the other components in this project. So we've got this cake file. Now, cake stands for C# make. So it's effectively it's a building engine. It's a build engine, but the thing that's good about this is that it's cross-platform. So we can use it to do build executions on my Mac here, as well as on Windows. So that makes this really sort of attainable and gives developers a choice around what they want to use.
Right.
And we've got two files here. One of them is a PowerShell script. So this is the entry point. This is going to help us invoke this Lambda function. So we can integrate these scripts into our continuous integration and continuous deployment pipelines.
Nice.
And here's one for Linux-based systems. So a shell script that basically executes the cake command. Now you don't actually have to do anything with these other than use them to execute the cake script.
Cool.
So that's a quick overview of the project structure. But I think before we start coding the project, maybe we should actually build the workflow.
Okay.
What do you reckon?
I'd say let's do it, because at least I think it's a more visual representation.
Okay.
I think what people will realize, you can carry on, I can speak about
Sure.
that now. What you ended up realizing as you're building this, especially in .NET Core, is most of the work in the Lambda function in particular is going to be super simple, because all you receive is an event and you also receive a context. So you define that request handler in your code, as Steve was showing. And the step functions is, in this case, or the whole workflow, the whole business process that you need to do, that's going to take most of the time. And that's actually what we want. We don't want to spend any other time that's not adding value to the business. So, right, so we got this Amazon state language, which will help us define the state machine, right?
Yeah, exactly.
So how do we go from here, Steve?
So, so I just wanted to quickly show you the specification. This details all of the things this has all of the things that you need to actually build a step functions, and it details a lot of the concepts and the types and some of the types that we're going to be using today. So it's for example, we can see here, we can go through, we talk about states and the things that we're going to be using to execute our workflow, to build up our workflow, how information transitions from one state to another,
right.
How to deal with timestamps and reference paths inside our our specification. So this is open source specification, and effectively to build a step function, all of this is just JSON.
That's
right?
That's pretty powerful.
So
cool.
you can imagine that you can do some really interesting things with this, and it's really straightforward to build. So we can see here we've got information about all of the stuff that we're going to be needing to doing today. So
Okay.
so let's use some of that and build it. So in the state machine, so when we go to step functions in the console, I could build the state machine in my development environment, but in order for us to get a nice visual representation of what's happening, we're going to use the console, and we've got a couple of different options. We can author one from scratch, or we can use some of the predefined templates that we have. And so the first thing we're going to do is, and so you can see here, we've got some of the some templates that describe or show people how they can implement some of the states that we have available. So for example, we've got await states and a retry, parallel execution modes, and how to deal with choice and capture. So we're gonna use some of these states in our workflow. But to get us started, we might just start with the hello world.
Cool. Just before you go on, Steve, on this, I just got corrected, which is something super cool. I didn't know that we actually have the state language on GitHub.
We do?
Did you know that?
I did not know that.
That's interesting. I posted a link on the chat, so we actually have the state language, the website, actually on GitHub. So yeah, that's
Awesome.
pretty cool.
That's great. Right, so where are we at? Okay, all right. So every workflow needs to start somewhere, and that's what we're going to define here. So this we've got a number of states that we're going to be building inside the states element here, and we're going to start with the hello world state. But for our purposes, we're going to go register incident.
Steve, can we increase the text a little bit? Maybe just do a zoom on the browser. I'm just
Sure.
looking to see, at least for me. Okay.
Is that
cool.
better?
Yeah, much better. At least for me. Hopefully on the streams as well. Okay.
All right, so register incident is going to be the first part of our workflow. Okay, we're just going to rename that. And while we're building this up, so we actually want to be able to see also what's happening here.
So I'd say it's okay. As soon as we need that, we can actually go back and forth.
Right, okay. So what we're going to do here, just to sort of get the components ready for us to start creating Lambda functions, because there's a bit of a chicken before the egg kind of scenario here.
Right.
We need to obviously build up our workflow, our state machine, but we also then need to also build the corresponding Lambda functions for those states that are going to be implementing a task.
Okay.
So for now, what we're going to be using is just a pass type.
No, it makes sense.
And the pass type really it's just a pass through. There's nothing happening, but it's going to help us, formulate the structure
Kind
of
of
our
visualize.
Yeah.
So this will be a tip that you will give any developer trying to build this from scratch.
Yeah.
Instead of hammering the code straight away, just build the business workflow that you need to get. Use the type equals to pass, and then, we actually build this to make sure that we can go one step over the next to make sure the whole flow is actually respected and followed. And then later we would change this to a task where it can have Lambda functions to be executed and everything.
Absolutely.
Right. So let's do that.
Okay, cool. So, all right. So obviously we don't want this to end now. We want to actually create another task. So we're just going to do a bit of a copy and paste job here. And we're going to go, right, register incident. What was the next step in our workflow? So it was, once we've registered an incident, we were going to schedule an exam, right? So we're going to schedule an exam, all right? So that's our next task in the workflow. And we want that to be the next step. So rather than saying end, true, we're going to specify what is the next step in our workflow. We need to make that a string. Okay. And we can see here when we hit refresh on this.
It should be a little bit to the right. So maybe you just take the zoom out.
Yeah.
And let's refresh that.
And then you can see here, we can start to see, right, okay, our workflow is starting to build up.
That's pretty cool.
All right. So, right, what was the next step? The next step is going to send an email, right? We need to send a student a notification that the exam has been scheduled and that they have 1 week to sit the exam and hopefully pass it.
Oh yeah. Well, we want everyone to pass. By the way, we're not mean. We're just doing the business process, right?
Yep. So send notification. All right. Send notification, and we're gonna make that the next step. Cool. All right, and I'm gonna make that a string again. Keep forgetting that. Cool. All right. So once we've sent once we've send the notification, we need to we're gonna wait for that week to that exam deadline to pass. So in this instance, we're going to create a wait task, and that wait task needs to have a duration associated with it. Now, once we start building this out, we're going to specify this time dynamically.
Right.
Based on when the exam was actually registered, right? But for now, we're just going to specify a time to wait. So we're just going to wait 10 seconds before we can continue on our workflow.
Is that all you need? You just pass seconds and that's it?
No, it takes a relative and absolute timestamps as well. So you can specify a specific point in time to wait for.
Okay.
In the future, or you can say wait X amount of X amount of time before you continue to execute this workflow.
See. That's pretty cool.
Yeah. So
okay.
that's
the type wait, and that's exactly how you can wait for up to a year.
Exactly.
But obviously nobody wants to wait for a year.
And what step function is going to do during that time is going to persist and make all of the data that you've captured throughout this this execution, and it's going to persist all of that data and make it available. So when you do kick off that when you do kick off that workflow,
right.
all of that information is going to be there. So what that means is basically, because step functions manage state for you as well, it means that you don't actually have to provide a persistence mechanism yourself. So what I mean by that is you don't have to have a database that you need to manage, and then making sure that you're coordinating these activities and all of the respective executions and pulling the information back and forth. That's all part of this managed service.
Yeah, I think it's also important to say that this is actually perfect, but there are some scenarios that you may want to have a large state. You definitely don't want to put everything into a state machine in step functions.
Absolutely.
Maybe you want to actually find a balance between how much do I keep that state in that execution, because once the execution is gone, everything is gone.
Yeah,
right?
Absolutely. So if you need to persist state afterwards, after the execution is finished, then you need a database or some other kind of persistence mechanism.
Cool.
Or you might be using, during an execution, you might be using very large payloads to do some work. And that's not a great place to put that stuff, right?
Sure.
But you want to be able to keep the references to those payloads inside the workflow, so you know when to your implementations know how to retrieve that information.
Perfect. Okay, so we got register incident, we got schedule, XM, and then we got the send notifications. Do we continue, or do you want to test the state machine?
Let's test the state machine.
Okay.
Right. So an easy way to do that is let's just save this.
It's going to be on create state machine at the end, right?
At the bottom, right? Create state machine. Right. So here we've created this state machine, and the next thing we're going to do is going to start an execution. Right. So this is how we can test stuff, and then by starting an execution, we can enter the payload that we're going to be needing.
Okay.
Right.
Let's actually add a fake payload. Let's just say student ID, and then
let's do that.
And XM is going to be let's say maybe XM is going to be an array. I remember seeing something like this.
Student ID is 1, and the incident date. So when that
incident started.
So when that student committed the violation is going to be a date. All right, so 2008. So this is February the 12th.
Okay.
All right. So we're going to use that. That's going to be basically what we've passed in from our web application.
Okay. We also need to give it a name to the execution, right? Or is that optional? Oh, that seems
it is optional. If we don't enter a name, then Step Functions is just going to generate a unique identifier for that.
Okay.
All right. So we can uniquely identify this execution.
Okay.
And here we can see we've
fast.
passed through because we're actually not doing anything.
Yeah.
And then we're going to wait a few seconds, and then hopefully when we're done, all right, you can see it's waited, we're done.
That's awesome. Can I see the input that I received? I remember you saw something like this.
Yeah, so here's the input.
Here we go.
And because we're actually not doing anything, this is actually a hello world, because that's the result that we've passed back to the machine. But
exception.
So you can see along the way here.
What was the input from the previous task?
Exactly,
etc.
The output of the previous step becomes the input for the next one.
Which is interesting. And I can also merge those results inside my state language definition.
I can pick and choose elements of the payload that I want to pass to the operations that are actually executing on those steps.
What's that execution event history right there?
So this is basically showing us the execution flow and how long things take. So we can see here in the first step, we started the execution, and then it's got information about the states in which the execution history for this entire workflow. So we can see when something entered, when something exited those states, and the input and output values for each of those. So. And this is really important, I guess, from a debugging or a monitoring perspective, because we can find out what's our current execution state. So anything that's not a long running, we could interrogate this event history to find out where is this execution currently at.
Got you. That's actually really interesting, especially for any sort of investigation right after, and I can obviously get all this data via API, and I can programmatically do all these pieces.
Yep.
What actually intrigues me is you can carry on, because I know we have a lot to cover and we have not much time yet left. But one thing, I worked in the retail for quite some time, and one of the things that quite interesting for me is that I could have a state machine with my, let's say, order management workflow. I could see the whole order being placed, checking the warehouse to see if I have any items, and I could go back and forth. Sometimes I need human intervention that will take a while, so I want you wait for that to happen, and then carry on. And the good news about this is that because all of these states actually are just on one API away for you to know where exactly is, and yada, yada, yada. I could simply actually have a front end to keep updating my customer to say, this is where we actually are. We're just checking your product in the catalog right now.
Yeah.
We actually have someone waiting to collect your order or something like this. And that's pretty cool.
And a really important element for us to be able to do that is this execution ARN, right? So this uniquely identifies our current those executions, so we can track that inside of our applications to be able to interrogate each of the individual executions. And when, as you saw at the demo, that's precisely what got returned to me when I executed that from the web page.
That's pretty awesome.
So all right. So we've got a couple of states now, because register incident, schedule exam, and send notifications. These are things that we need to do. So we might pause here, and we might start, just elaborating a little bit and start providing some implementations for this work for the workflow that we've currently got. So let's build let's start with the register incident side of things.
Cool.
All right.
Exciting times. So let's actually do the thing now in .NET. It's something cool because I also want to learn .NET even better.
All right. So where is Writer? Let's pull up Writer. Okay. All right. So let's just close some of these windows. All right. Let's close all these windows, and we're going to go to that first state, and we're going to modify this. And we're going to we don't need this implementation. We're just going to get rid of that, and we don't need that either. All right, so let's get rid of that. Now, a couple of things that you need when you're actually we don't. Yeah. A couple of things that you need when you're developing a Lambda function with .NET Core is a serializer. Okay, so this basically just helps us. Helps us serialize the events that get passed to the Lambda function from the various services. Because we have different types of event sources, so it could be S3, could be API gateway, could be a DynamoDB stream. We just want to make sure that we've serialized that event payload appropriately. So this attribute is required for that to sort of work effectively.
Gotcha.
Now with our function, with our function, the SDK also provides a number of predefined classes that help us actually map those events map those events to a C# object.
Gotcha.
And in this case, this is an example of how you would consume an API gateway proxy request. And pass that into the Lambda function.
Right, but we're not going to be using API gateway, right?
No,
so
we're not going to be
relevant for us.
Yeah, this is going to be irrelevant. I just wanted to point it out that there is an entire NuGet package that lists all of the events that they're not all of the events, but there's a good number of events that classes that we have available.
Right.
Now the other thing is that we also have, and you may have seen this in other languages, that we have a Lambda context. Now this is in C#. This is optional. If you omit this,
cool.
Lambda will actually inject that because it's a really important part of being able to
I didn't know that.
Get information about the execution of your Lambda function. We're going to leave that in there. So the first thing we want to do, because we're working with step functions, is we want to actually create a way to get some state, right? So we've got an input. We need an input that represents our input value, and for that, we probably should create a strongly typed class that represents the state that we're going to be passing through all of the functions.
Makes sense. So we don't repeat ourselves later.
No, exactly. So we're going to use we're going to create a object called state. Now we haven't got that. Sorry, a class called state. Now we haven't got that class. So we're going to just create a class called state, and then we're going to start this state class is going to have all of the properties I'm just using. One of the nice things about Writer, by the way, if you see me typing, this is not a default thing. It actually comes embedded with what's it called again?
It's kind of an autocomplete intelligence for Visual Studio type of thing.
I forgot what it's called now. It'll come to me in a second.
It's okay.
But anyway, it gives you a whole heap of functionality. Right, so the first thing that we want to capture is the student ID, okay? Now that's just going to be a string, student ID, and we're going to give it a name. All right, so the next thing is going to be what's the next thing? It's going to be a datetime object. And that datetime object is going to be the incident date. Can everyone see this?
Yeah, it should.
Yeah? All right, cool.
I can see that.
All right, cool. And then what else do we need? We need an incident date. We need, forget what we needed. Let's have a quick gander. All right, a little reminder, a little cheat sheet. All right, so we've got an incident date. Then we need an incident ID, of course. Okay. And we're going to make this a good. All right, so we're going to create a unique incident ID. So the university that can track that later on. Then we also need a resolution date. So we're going to create another property called resolution date. And this is going to be, this is going to signify when this incident was actually resolved.
Right. Okay.
Right. So then we need a list of exams. So we're going to create a class called exams, and we actually need to create a type here to capture all of the exam information. So we're going to create a class called exams, and those exams are going to have some other unique properties. Things like we need to maybe have let's scroll up here so people can actually see what's going on. We need an ID for the exam. Then, oops, let's call that exam ID. Cool. What else do we need? We need to know when the exam is.
It's about to be due.
When it's about due, so we'll call this exam date. Or we can call it exam due date. Right, so that's going to help us with that business logic to determine when to set that timeout. Right.
Right.
And then we are going to create a property called score. Right. So we need to. What did they get? What score did they get? And then just to help us with the workflow execution, it might be an idea for us to be able to, rather than sort of passing off the that business logic around whether or not that student has passed to the state machine, because we can actually do that, right? We can use in a conditional state. We can do if then. We can do a whole heap of logic. But we want to be able to do that. But we don't want to be able to pass the logic to that step function to help us determine whether or not that student has passed the score. We just wanted to make decisions about the path of execution based on whether or not they've passed or not. So so let's create a property here called what are we going to call it? Result. Let's call it result. And we're going to give it we're going to make this result. Oops. Let's try that again.
We don't actually need an interface. Come on, writer.
Come on, writer. Bloody writer. All right, so, and we're going to call this property result. Now, we don't have a type result. We're going to have to create a type result. But because we've got because we only need to, we don't have the class for this. What we're going to do is create an enum. So an enum is basically allows us to just specify some predefined value. So the first enum that we're going to create is called pass. The next one's going to be fail, and we also want to check to see whether or not they sat the exam, because if they didn't sit the exam, right?
Yeah, they will automatically fail, right? At least for
automatic fail, yeah, absolutely. So let's just put they did not sit the exam. All right. So this might be enough to get us started, and we can build up these classes as we go along. Now, because well, we need to let's just create an empty. Let's just instantiate this class. Okay. No, we don't want it to abstract. All right, let's just create a constructor here. And when we create a new state, we just want to create a new list of exams, because we could potentially have more than one list, right? So when we create a new exam, we're just going to create a new list of exams. So we'll initialize this. We're just going to initialize that object so we don't have a null object when we first create it, and we can start using it.
Now it's slowly I'm starting to understand all this input output and how this makes sense. Yeah. I remember having an array of exams, and now it makes sense to me.
Now this state is currently embedded in our register incident project.
Yeah.
But we're going to be using this state in other places.
In multiple functions.
Exactly.
Right?
So we need to create a new assembly for this. So let's create a new project. And we're going to get a class library. So let's make sure it's .NET Core. It is. And then we're going to call this class library, well, what are we going to call it?
Maybe just call it a state library, or...
Yeah, let's call it state library. Let's just call it, or
student or
plagiarism incident.
State?
States.
Okay, so we know it's at the state for that particular case. Okay.
All right, so C#, .NET Core 2.1, we're ready to go. Right. So we're going to create a new library for that, and then we're going to move all of those stuff that we've got in here
to that one. Okay.
To that class that we've just created.
Right.
And then what we need to do is draw a dependency on this class. All right. Let's just make sure we've included the missing.
This is what I love. This is what I love about strongly typed and IDEs, which unfortunately I don't get in Python. Although I can prototype very fast in Python, this is something like all this autocomplete.
Yeah, it's very handy, isn't it?
And all of this actually constructs and everything else is so much easier.
Yeah. So we're just going to we're going to rename this class just to make it a little bit more. Let's rename this, and we'll call this state CS. All right, cool. So, all right, so we've done that, and now we just need to fix this up. So we need to draw a dependency on this class. We're going to reference this project inside of the register incident Lambda function, and now we've got a reference to the state. And we can start now going. We're going to rename this as well. Call this state, just so we know what we're talking about, and then we can go state exams incident. We can start, setting some values for this class. So, but because we want to so we've got our input, we also want to create an output of the same type.
Absolutely.
So where this function is going to be returning a state as well. So our return type is state.
Oops, there's an R there. Okay. Okay.
Cool. All right. So so that's our first class. So state is going to be the incident date is going to be the state. Oh, we probably should. Sorry, not the incident date, but the incident ID is going to be a new GUID. All right. Right. So we've just created a new incident ID, and then let's just do a return type here. All right, we're going to return the state, and what we can do here is go state. What else have we got?
We also have the incident date.
Yep. So resolution date we can leave empty, so we don't need to worry about that, and so that should be pretty much all we need to do. We've got to create an incident, and we're going to pass that incident back to the what do you call it? The
let me just actually bring this up. So that's going to be the schedule exam.
Yep.
So all we need is that it? Well, all we need to do is just to generate an incident ID and return that.
Yeah, pretty much. All right. So that's pretty much it. Right. Let's just do that. We could.
Okay. In the meantime, you do your thing. Let me just share the whole open sourcing here in case you actually need it. If you just joined it right now, let me actually share this with you. This is the end product. The end product that's now open source. And if you just joined right now, we order to bootstrap this entire application, get all this X-ray, all these Lambda functions, constructs, and everything. We used what we now open sourced as well, which is an advanced template for .NET applications when using SAM. So if you have SAM installed, all you need to do is actually, let me just type this in. You have fast prototyping template. If you run this command when you have SAM CLI installed, that will be able to bootstrap the whole application we are building right now, giving the whole Lambda function structure, all the basic dependencies in order to get something fully working. That command will be able to do that for you. Although that uses API Gateway and we are not using API Gateway, that should be able to give you a really head start when it comes to fast development for .NET.
Yeah. So let's fix our test while we're at it, because our test is no longer relevant, and we're no longer getting a response. So we can do this. We might fix this up a little bit later and just sort of crack on with the rest of the development stuff. Okay.
Cool.
For now, I might just cancel this stuff. Oh, whoops. For now, I might just delete that. Oh no, it's not delete that. Let's just copy this out. Oops.
Okay.
Okay. This is really difficult to do when you're looking up all the time. Okay. All right. Cool. Okay, so that'll at least compile. There won't be any errors when we do a build.
Okay.
All right.
Yeah.
All
Okay,
right. So
that's
let's just rebuild this project. Make sure we don't have any compilation errors, and we should be ready to go.
So does that mean a writer automatically integrates with Cake, the build process that we explained initially?
No, it doesn't.
Okay,
So this is a
different
separate build process. That's just standard, sort of standard .NET.
Standard
stuff.
C# stuff. Okay.
All right, cool. So now we've got, now that we have the register incident function, we want to schedule the exam. All right, so we need to create another function for that. Now, theoretically, I could actually embed all of this stuff into a single function, and but that kind of it gets a little bit messy, particularly when you've got when you start to create modular components inside your application, or you want to be able to have a one-for-one kind of one-for-one sort of project structure.
If I'm thinking about time right now, because we're at 10 o'clock, is it possible to build that as a function right now and actually do the wire up on a state machine to have a single function to register the incident ID and return it? How can we do this?
Okay, so we want to make sure. So so we go to our template, okay, and so this hasn't changed all that much, okay. We've still got everything sort of set. We don't actually have any environment variables. We can sort of get rid of that. We don't have any of those right at the moment. We want to keep tracing on. We want to return the incident ARN, and we've got an incident ARN role, which is basically automatically generated by the serverless application model.
Right.
Now, in order for us to deploy this, let's open up our terminal here. So all we really need to do now is we need to do a couple of we invoke the build and package command for our Cake script.
Right.
Now the Cake script is, take another look at this. Let's just see what it does. So it's basically going to, with all the compiled languages like Java and C#, what we actually need before we do a deployment, we need to package everything up, which means that we need to compile all the source code and then zip it up, and then we can send it off to AWS and Lambda to actually deploy it. And so what this Cake script does, it does all of this stuff. So let's scroll down here. We can define some tasks. So we've already built some tasks that allow us to run our tests, our package, and package our application. So what this does, rather than if we've got, once we start, you'll see the benefit of this once we start getting more and more projects that represent Lambda functions. It actually will package, run all the tests against our projects, and then it's going to create all those zip files. And so what we need to do is make sure that, and all of those zip files are going to be put into an artifacts directory. And so we need to make sure that our code URI is the actual artifacts directory for the respective application. So when we build this up, you'll see. Okay. So the first thing we're going to go to, just to sort of see this in action, let's execute the build sh. And we're going to give it a target of package, and that's going to run. You'll see here. It's going to download all the tooling. It's going to download NuGet, and it's going to restore all of the packages for our project, and it's going to run all the tests. Now the tests might fail, so we just need to make sure that that's all good. So you can see it's starting the test execution, and then it's going to package, and then we get a nice little summary at the end. Okay. So we can see here now in our project, if we open up our, if you
actually do a ls, you should be able to see that, right? Oh, here we go, artifacts.
So I just want to show this visually. You can see here, here's our artifacts. And if we open this up, if we open this file up, we can see it's got all of the DLLs required to execute our Lambda functions.
So you start there for a minute, so before we just go ahead and deploy. So essentially in .NET is very similar to for Python and any other language, except Go, where we need all the files we need in that particular root directory or root zip file, DLLs, all the dependencies, including the state class that we just actually draw into the application, right? And once that's done, Lambda will take that zip file, deploy as a Lambda function, and then when we send a request, SAP functions or API gateway, for instance, that will invoke that handler that we defined earlier, that function handler.
Yep.
Okay. Cool. How do we deploy this now, Steve?
Okay, so now that we've got our package, all we're going to do is run a couple of SAM commands. If you look at the docs as well, you'll see that we've already kind of we've given you the information on how to do that. So let's just quickly open this, expand this a little bit. So down here, we've got, first of all, we need to make a bucket. All right?
Right.
So we're going to create a bucket on AWS. We're just going to execute this command. So this, I've already got the AWS CLI, but you need the AWS CLI installed and configured. You need to make sure that you've got appropriate permissions in order to make S3 buckets.
Okay.
But as I'm the master of my own domain, I'm going to do that. Now I'm gonna create a new bucket called what am I going to call it? We're going to have to call it Twitter Plagiarism. Not Twitch. Twitch, not Twitter. Struth. Twitter.
Oops, not Twitter. It's actually Twitch.
It is Twitch, isn't it? Thanks, mate. So we call it Twitch Plagiarism.
And just say dash.net in case someone was also doing the same thing for some reason somewhere else on the planet.
All right, cool.
And we're specifying the region because we are in Australia, right?
Yeah, exactly.
Cool.
So I just want to make sure that the latency is as close to good as possible. And being in Melbourne, it's going to be really fast.
Yeah.
So I'm just going to make this bucket, and hopefully there's.
Okay.
Good.
Done.
So now we've got it. So we're just going to. I'm going to copy this because I'm not going to copy that now because I want to copy these other commands. So first of all, the next thing we're going to do is we're going to package our template, and here I'm going to replace the bucket name with the bucket that I just created. All right. So this is going to be. Oops.
Oh, I don't think that's gonna work.
No, that didn't work.
I think the easiest way to do is create a new file in your IDE, copy those commands because you're gonna use this multiple times.
Yeah, exactly. All right, let's do that. And let's just, is there a text file? I don't usually use writer. Hang on a second.
So
let's just do this.
Okay.
I'll open up a text editor and I will copy this command. Why isn't it copying? Yeah.
What I find funny about Twitch is when you see that something going live, you see the struggle. And even sometimes it's a basic thing. Sometimes you copy and paste something, or sometimes you just you just need to do something in the terminal, and the terminal ends up doing a new line, and you go back and say, come on, I just need to do a package and deploy.
I know.
And this is what I like about doing things on Twitch, because it's something more real. It's not something that you just kind of copy and paste everything, etc. all the time. Right. So,
okay.
So let's just change the bucket name to that. And by the way, whenever you're doing this, my suggestion in the feature is always to try to do something like code snippets. I use Visual Studio Code. I don't use Writer or anything like this. Sometimes I use Sublime, and especially Cloud9 as well on AWS. What I normally do is I have snippets in all these IDEs. Whenever, all the time when I'm trying to do prototype, I have SAM package, I have SAM deploy, and all I normally do is just say sam-cli, and it gives me all these commands that I just need to replace those pieces with it. So it's something, as a suggestion also for the viewer and also for the feature. It's something that helps a lot. Here we go. We have SAM package, and let's try to run this and see if that, you need to pass the region, right? Or your default region?
I've already got a default region.
The default region is the same as we created the bucket.
Yeah.
Okay.
So, so I've got my profile is set to the default region to Australia. So just so you know, that's why we didn't include that.
Sure.
So what this command basically does, it just says, here's my template, my SAM template. I'm going to I want that to be passed, and then what that passing does, it basically substitutes the location of our local code URI with the location of the file in our S3 bucket. Okay. So now when I go to deploy, the API knows where to find my deployment. So and then it says, okay, and here's already given me the command to execute for that next step. Now all I need to do, I'm going to be using CloudFormation here to do this, is to execute that and give it a stack name. So let's just do that quickly, and it's going to wait for a change set to be created. So for those of you who don't know what a change set is, okay, so there's an error. So what have we got here? Template error, instance of get at is undefined resource register incident. Okay. Register incident. Incident get at references undefined. Because the name of this should be get an incident function, right? So we've got a bit of a bug there, so I need to fix that later on. But yeah, so let's just try that again. Let's save this template file.
And we need to do a package and deploy again.
Yep. So we're not
go ahead, and Steve. For those of you asking those questions on the chat, I just want to see Steve doing the package and deploy, and then we can actually go and just explain very quickly the template.yaml once again. So let's actually do this. It's just missing. Okay.
Hang on a second. Sorry. All right, let's just do that. Let's just.
Okay. So to kind of give you a better overview, what's happening is SAM. When you define a template using SAM, I can give you the link right now again for the template demo that we already built previously. The SAM template will actually create a Lambda function, in that case, AWS column serverless function. It will look at the code URI and we do the package as a zip file for us, which is already zipped, so we're just gonna ship that to an S3 bucket that we already created. Only those lines is actually sufficient for SAM to already create an IAM role for us, give the minimal permissions so Lambda can execute, and also ship the logs to CloudWatch logs. Every execution that Lambda every time Lambda gets invoked, all the logs get automatically streamed to CloudWatch logs, so it centralized everything. If we were to set something like events and have API gateway to call this function, we would be able to have, including the IAM permissions from having API gateway to invoke the Lambda function. So all of this is actually being wired up by SAM. SAM actually stands for Serverless Application Model. I will send you the link right now, but that should be able to give you a quick summary of what's actually happening behind the scenes.
Okay. So I've just realized that, because I've got multiple profiles, I've actually just deployed this to a separate account. So let's just do all that stuff again.
Okay.
There you go.
So this is the reason why I use the snippets for that.
Now this was a configuration of my profile.
So you have choose less in there. That's gonna fail.
Yeah.
Okay.
And that's okay. For some reason, it's not remembering my.
Cool. And also the SAM package that we are using right now, that's wanton for your information, is part of a CLI for SAM. SAM is actually doing so there are two parts of SAM. There's what we call SAM translator, which is responsible for getting that template.yaml and converting and exploding or translating to something that CloudFormation understands. And the commands, the CLI, the package, the deploy command, or initializing a project from scratch, looking at the logs automatically, all from your CLI, and even doing local development, that's actually done by this CLI that I just shared with you on the chat. Absolutely. So once you do a deploy, what actually happens, it actually creates a change set, so you can see what actually things are happening right there. But when you do the CLI, it doesn't allow you to stop to see what's going to be changed. When you do that in production, for instance, all of these commands that we're doing, you don't use that. All you're going to do is something like git add, git commit, and then git push. That's actually all you need, really. If you actually have this template and upload to CloudFormation through the console, or if you just don't use SAM deploy, you can essentially do CloudFormation create change set and then see what's going to be the changed, and then you do it again. AWS CloudFormation execute change set. What SAM deploy does as a command line, in fact, is actually doing both executions at the same time. It creates a change set, and if it change set it's created successfully, there's no issues or no circular dependencies, things like this that can happen, similar to Terraform plan, and then it would do a CloudFormation execute change set. All of both of them are actually wrapped in a single command called deploy. Deploy, create change set, execute change set.
Okay.
Sure, I will do that. So the terminal that you're showing right now, Steve, is actually being covered by the camera. Can you bring the terminal to the right-hand side? In the meantime, you're fixing some of those little things.
Yep.
So thanks for actually thanks for bringing that up. I wasn't actually looking at the stream. Now I'm looking at right now. Here we go. Now we can see that now. So Steve actually just made a mistake, and we're trying to recover from that. So Steve, what happened there? So can I help you with that?
So because I had the wrong profile enabled.
Okay.
I've basically have to recreate the bucket and all the rest of it.
Okay.
So now we've got the bucket. Now we can execute our test. Unable to artifact reference.
Then you should put a -- profile, Steve.
That's because I've got the wrong bucket name in the.
Okay.
Let me just fix that.
Okay.
Because it's a unique bucket in the other region, I need to in the other account. So it's still, what's going on?
So I would suggest putting a -- profile. That would help us get it back to. So let me see. Twitch Plagiarism. Is that the bucket that we create in that region? So your region defaults to Sydney. Is that correct? Okay.
Yeah.
And your profile is called demo, if I remember, right?
Yeah.
So let's do a -- demo profile, and let's see how that goes. So the bucket doesn't exist. So let's go back to the S3 bucket. That created a bucket, but that created a bucket in the wrong place, in the wrong account.
Okay. So I've got a bucket here.
But that's if you do a -- profile demo. Is that right?
That is the demo one.
Okay, cool. I think we had a typo there. Go back to the SAM package. So yes, we had a typo. That's why there's an additional S in there. Okay. Do you want to do a -- profile demo afterwards?
Right, here we go.
That's a typo there.
All right, let's just.
Here we go.
Hey.
Okay.
All right.
Here we go. Thanks for explaining the typos.
Live Stack Overflow.
Okay, that's what it is. So my heartbeat was like, oh my gosh, let's actually get this deployed.
Okay.
Okay.
All right. Now we're ready to go. Okay. Sorry about that, guys. Right. So let's just deploy that.
Do you need to pass that profile? Is that already exported?
No, I've already exported it.
So let's do this just in case we lose this terminal, lose something. Add -- profile to your cheat sheet command line that now you have it. And just to make sure that we're not gonna get to this. By the way, want to now that SAM deploy is now deploying the thing in the way it should be. So what's happening right now is essentially, like I said, creating the change set. Change set has been created successfully. Now we will basically create the CloudFormation stack, or is executing the change set. I don't think we're not going to have enough time for doing all of this today. Very unlikely we're going to be able to finish everything. So we're going to do a second part to finish the other pieces. Even the state machine that we created through the console, we will be able to do this, everything in the same SAM template. All the Lambda functions, the API gateway definition, and integration between API gateway, state machine, etc. I don't think we're going to be able to do this in this episode, but let's at least actually create one Lambda function or possibly two. Make sure we can wire that up to the state machine. If that works, perfect. And then for the second episode, we actually finish the rest of the Lambda functions and we wire up everything else.
Cool. So we can see here that Sam's actually created all these resources for us. So we've got our Lambda function. We've got, you can see here. Okay, so there's the Twitch plagiarism register incident function, and that's all ready to go. So we've got X-ray hooked up. It's all ready to rock and roll. Cool. So let's just go back to our step function. Now we're gonna now we need to integrate this into our workflow, right? So let's go back to here and let's edit this here. So rather than pass, what we're going to do, let me just zoom in here for you. Rather than pass, what we're going to do is we're going to specify this type as a type task.
Right.
Okay. And because it's now asking for something, we need to give it a resource to execute. Okay. And that resource is going to be the Lambda function. So we've got some nice IntelliSense stuff going on here in the console.
Nice. Here we go.
That allows me then to actually implement or select the Lambda ARN that we've just created. So I'm just going to select the Twitch plagiarism register incident function and embed that in there. And because because the Lambda function is passing out the result, we don't need to have that result thing here. So now that we've got that, let's save this and let's start an execution and see what happens. All right. So again, we're going to use student ID.
So in the meantime, Steve is actually doing this. I'm just going to answer your question live in addition to actually putting that on the chat. I will leave you another template that you can use to also generate a CI/CD pipeline and share with you the video that I did last two weeks ago or so, that I did the whole creating unit tests and creating a pipeline, creating the build, creating artifacts, and actually migrating or moving away from SAM package, SAM deploy to something more at a Git push perspective. So when you create an S3 bucket, for instance, for these particular packages, it's very likely in the development that you're going to use the same S3 bucket for you only on your personal developer account, that you have full access to do anything. And all your SAM package for multiple Lambda functions will be publishing this zip file to the same S3 bucket. And then SAM will be able to do all the hard work of actually wiring that up into every single Lambda function deployment to use the correct artifact.
Okay.
So what happened there?
So we've got a permissions issue, right? So we have to remember that we also need to provide step functions with the permissions to be able to execute a Lambda function.
Gosh, that's totally correct. And we don't do this because we're creating the step functions through the console and not through SAM template. That's actually right. How loud is this done? Okay.
Yeah. So right. So let's go to our state machine. We also need to let's have a look at the details.
So you need to get the IAM role over there, the second line, all right? And you need to give permissions to invoke Lambda functions.
That's right. So we're going to take this role, just going to do a quick search. We go to IAM.
Exactly this. So in the meantime, Steve just fixes this problem very quickly, is just doing a search. So the way I like to do is when I'm developing on my sandbox account, what I normally do is I try to define everything as infrastructure as code first, and I do basically local developing using Lambda and API Gateway. If I'm not using API Gateway, I just use the SAM local invoke, and I simply pass an event.json that mimics with the same payload that my Lambda is going to execute. Once the Lambda function wires up, works pretty well, go back to my infrastructure as code, and I make sure that the event that's going to call my Lambda function has the permissions to do so.
Okay, so what's going on? This is probably the wrong ARN, isn't it? It is. So let's go back to our roles.
Is that the right account?
Yep.
So that's the right account.
Yep. Okay, where is...
So go back to step functions there. We have a neat features in the console. Okay, cool.
Okay. So we're going to create are we going to create an inline policy?
Yeah, so go ahead and fix that very quickly. I'll explain to you. We only have 30 minutes, by the way, so don't worry. Yes, that's our recommendation actually, and that's something we are also working to update this white paper. So the white paper is called Serverless Applications Lens. We're currently working on a second update as we speak to actually give more prescriptive discussions, prescriptive advices on that particular regard. The reason I recommend, or AWS in general actually should and we do recommend developers have their own account for their own stack, is when you're trying to develop things, the least you want to be concerned is actually making sure that you don't have permissions to create a bucket or you don't have permissions to do something basics. The good piece about serverless in general is the POC cost that used to cost something like, I will need X amount of virtual machines and something else, and then in prod I would actually probably have 4 times more memory than the usual. In servers you don't have that cost. Actually, you're only going to start paying after 1 million depending on what you're doing. And having a developer having its own account, making sure that they can, they tweak around using SAM package, SAM deploy, and all of these pieces, or even just setting up a pipeline from the get-go. And that simplifies the whole experience. Once that's done, the developer, in fact, should only have access to the same Git repo where a pipeline that will roll through all the other accounts, developer, pre-prod, production, etc., should only pick up through a pipeline. And the developer could also have access to read only in those accounts, and they can use switch role to see how what they develop in sandbox actually you see that's being actually executed on the other accounts as well. The reason for this is you give the whole promise of actually doing fast development, fast prototyping without having the hurdles of security or permissions or something like this. Once the developer knows how this should work, if they don't really wire up the infrastructure as code as it should be in a repeatable manner, the whole pipeline will fail anyway. So instead of actually going through this whole pipeline and actually having that being deployed in test, dev, test, pre-prod, etc., they can half that cycle and just say, my developer account works, my infrastructure code works with the right permissions. I'm 100% sure that this is going to work for the other accounts. So hopefully that gives you a better overview about all this. If you think that's a nice topic to talk about probably on Twitch instead of only doing the live coding that we do every month, happy to do so. You can also ping me on Twitter if you need. So on Twitter, and then we can continue that conversation as well. Because I don't want to put pressure on Steve because of time check.
Steve's under enough pressure.
So here's my Twitter account. Feel free to continue that conversation.
Okay.
And happy to brainstorm on that topic more.
Okay. So we've got some permissions issues here. Might need your help sorting that out.
No problem. Okay. What's it?
So in this, so we've got some IAM. We've got an IAM policy. Let's go back to our. So we've got our IAM policy here.
Okay. And that gives access to execute Lambda functions, right?
And that we have execute Lambda function.
No, actually, that's a role for the function. We need a role for the step function. That's a different role. So actually, go back in there. Go to the step functions console.
Why don't we do this?
You want to do? Okay, sure, that works as well. So let's create a new role for this then.
Okay. And we've got AWS Lambda role already predefined.
No, you. Okay, so are you creating a new role or are you creating something else?
I'm going to create a new role.
Okay. Okay, cool. Just click on Lambda role. You're not going to need that for now, but it's fine.
Yep.
Click on the JSON piece. Let me see so I can see.
Right, sorry.
Okay, click on X review. No, that's not going to work. Click on X review. We can do that from scratch. Don't worry.
Resource, everything.
Yeah. So click on X review. Give it a name to that role. Here's troubleshooting live.
Cool. I'm going to create that role.
Okay, cool. You create that role. Let's open up that role. Let me see 2 things there before you go to state machine. So I want to see you have the policies permission to actually invoke any Lambda function. Cool. Trust relationship. Do we allow step functions? Cool. Yep. Copy your role R. There's a button there, and let's go to step functions. And yeah, pass there. There's we use an existing role.
We need to refresh this.
Yeah. Here we go. Awesome. Okay, so if you scroll it down a little bit, we have the Lambda function aren't hard-coded.
That's all good.
Okay, let's create a new state machine.
Right. So what we've done here, just so you're aware, we've modified the configuration of the state machine.
Just before we go, why not try to do a start execution, see if your permissions are correct?
Yep.
Otherwise, we explain, people follow, and say, oh, they're broken as well.
Right. Okay.
So let's see if that works.
Okay. So let's go student ID. And we're going to go 1. And then we're going to go incident date. (2019) 9/2. All right.
Okay.
Let's maybe copy that so we don't have to. All right.
Hold that thought one time. I will explain to you in a minute. Okay. So.
All right. So we can see. Woohoo! High five. We're gonna high five or what?
There we go.
All right,
Oh, it's working.
Had to get one high five in.
Woohoo! So okay. So.
Nice.
Now let's explain to you what happened, why we failed, what else actually, why it failed, and one time we explain to you about the policies. Mind if I explain, or do you want to give it?
You go ahead, mate. Go ahead.
Okay. So when you create a state machine or any AWS service that will invoke anything on Lambda function, you need to give permissions to that particular AWS service to invoke a Lambda function you're about to invoke. And in step functions, we are explicitly saying the definition that a register incident that you're seeing, the green button over there, it's actually invoking a particular Lambda function. So the IAM role that the state machine will assume to have permission to do what needs to be done, needs to have permission to say, Lambda invoke function, this is the resource I want to do. Because we're going to be calling multiple functions and we haven't created those functions yet, we are just using resource wildcard star. Obviously in production you don't want to do this. Next is the Lambda function also needs to have permission. By the way, this was manual process because we're not using infrastructure as code, we're using the console. The Lambda console in particular, when we have the function gets executed and we'll stream the logs to CloudWatch logs, and we'll also stream traces executions to X-Ray. That permission has to be set. The good news, we are using SAM, or Serverless Application Model. You haven't even seen us actually doing all these pieces. SAM is doing all the hard work. So as long as you define your function using SAM on that particular template.yaml we had before, the logs permissions will always gonna be there. And if you ever add tracing equals to active, that will automatically not only enable X-Ray for that function, but also update the IAM role that the Lambda function had or it has, and we'll update the X-Ray permissions too. So that's handled for you, Wanton.
Okay. So just want to point out a couple of things here. So we can see that this was our input for our state machine execution, and you can see that the service has mapped that to the actual class that we created in our project. So we can see here in student ID and incident date have both been converted into the properties, the property values for student ID and incident date. And in our actual Lambda function, we're creating some additional, let's get rid of this, let's get rid of the terminal. We're actually creating some additional properties for the state, I should say. The next thing we're going to do is so we've got a resolution date that's just default to 0, and then I've got an empty exam or a list of exams that we're going to populate next. So the next thing you're going to do is going to schedule this exam. Okay. So the exam is we're going to create a new Lambda functions for scheduling the exam. So cancel. So what we're going to do, what is this? Right, so we're going to add a new project, and we are going to just create a standard class library, and we're going to call this Register exam.
You have a typo there.
Thank you.
No problemo.
Register.
Yeah, there's another S there. Additional S, remove. Okay, here we go. Register exam.
Register exam. Okay. All right. Okay. So here we need. We're going to call this class function. All right. So this is going to be our next function. And we're just going to copy some of this stuff out of the previous exam. So the previous. And we're going to grab this. And we're going to grab the function handler. All right. Cool. Okay, so we obviously need to resolve some of these dependencies. In order to do that, we're going to go back to NuGet. So we need a few things. So we have got some installed packages. We need the core. We need to add that to the register exam. We're going to say yes. Okay, so we're going to add the NuGet package for amazon.lambda.core to this project to get things like this Lambda Serializer. We also need these two. Oops, cancel. Register exam, we're going to add that there. Yep. And we're going to add this to the register exam as well. And that should, you can see it's doing some work. It's just downloading some stuff from NuGet now. Just give us a moment while it's doing its thing. While we're doing that, let's call this class, let's rename this class. I'm going to call this function. Okay.
Carry on. I'm still actually talking to you.
Yeah, I'm just
you on the chat.
I'm just waiting for this stuff to.
That is correct. In the meantime, you're doing this so others can see it. So so at least we don't have no audio in this Twitch stream. Is if you're calling a Lambda function. Lambda function has to be called by something, by someone, by AWS service, or by whatever that is. Mm-hmm. If the event source is something that we support and SAM supports, the permission piece will be handled already, automatically. There's nothing you need to do. If you're calling an EMR cluster, for instance, that would call a Lambda function through code using SDK, for instance, yes. Then you need to define an IAM. So you need to define an EMR cluster through infrastructure as code. Terraform. Let's use Terraform, for instance. You would use Terraform to create an IAM role. That IAM role, you will need to attach policies, so you could have another model to do this for you. Let's say Lambda executions or Lambda policies. And then and that's it, actually. And then you do a Terraform plan, Terraform apply, and that off you go. If you use something else, let's say an EC2 instance that also needs to call Lambda function for whatever reason, for a microservice, for instance. In that scenario, you have to do that as well, because Lambda has no understanding that an EC2 exists. In fact, Lambda only knows about those event sources that we support and mostly serverless in that scenario. So hopefully that covers that up. But I also shared more information in there, and also shared you the magic. If you do SAM validate --debug, you will see something really magical happening. It will show you how we validate SAM templates The whole piece about permissions, if the permissions are right, if the resources are correct, there's no typo, there's no property we don't know, otherwise it's gonna fail later on. And also translates the entire SAM template to CloudFormation template, exactly what CloudFormation we receive. So you can actually copy this and see all those resources being injected, the permissions pieces and everything else.
Okay, so what I'm doing here, waiting for the NuGet dependencies to download and cache on my local machine. We're just going to create the implementation now for our function to register the exam. So what we're going to do is we're going to create a new exam. We're going to give it we're going to create a new exam object, and then we're going to exam due date is, so we're going to go, okay, the exam due date is actually the, because normally you would go something like this. You could go state dot incident date plus add the number of days, which would be 7, right? So in real life, this is what we would want to do, because that's the business rule. You've got 1 week to sit the exam from the day that the incident occurred. But because we're in development, we don't want to wait a week. Unless you want to be here, do you want to be in Australia another week?
Whoa, that's a personal question. I wouldn't answer here in Twitch.
Okay, so all right. So what we're going to do, rather than doing that, we're just going to go daytime now, and then we're going to add seconds. We're just going to add a few seconds just so we can see something happening in the console when we execute this this workflow. So let's wait 10 seconds, but note that this is really 7 days from the incident date. All right, so just so you know. And then finally, we're going to add a score. All right, and the score, because we haven't sat anything yet, because we haven't actually sat anything yet, we don't have a score. So score's going to be 0. All right, cool. So here we've got our exam. Now, what we're going to do, we also need to implement the business rule that says, you know, if the student has sat more than 3 exams, then we need to exit or we're going to throw a business exception. So what we're going to say is, so if the state and the exams is not null, which is a little bit of a check, okay, and if the state's exams.count is greater than or equal to 3, then what we want to do is actually throw an exception. All right, so we're going to go throw new, and we're going to create a custom exception here. We're going to go new student exceeded, exceeded allowable exam retries. All right.
You actually have a typo there, Steve.
Do I?
Yeah.
No.
You have a retires at the end. I think you mean retry.
Thank you.
No probs.
All right, and then we're going to pass in a message saying the student cannot take more than 3 exams. Cool. All right. Done. All right. Now this class doesn't exist, so we actually need to create this this class. All right. So we need to create this exception. And let's refactor this. And we're going to go, oop, we cannot. Right. And we're going to go back to our, because this is a shared thing, we're going to add this to our thing, our shared class. Right, so this is a public class, and we're going to call it that, and it's going to inherit the exception. All right.
Yeah.
All right. And so that should.
So there's red everywhere. There's a there's a red bulb in here. You know what that is?
It's going crazy because it's still trying to download the packages. So I'm not really sure what's going on. It's still installing the NuGet dependencies.
Okay, so I wouldn't worry for that. So we have 10 minutes left. Do you think we can finish for this Lambda function and see how that would work? Or
well,
should
not until we actually get all the dependencies sorted out.
Okay,
so I'm not really sure why this is happening. Bit of a glitch in the matrix, and demo gods are obviously against us. So what we can do, I suppose, is to build out maybe the next function, or
you know how I would suggest? I think we should stop here.
Okay.
Because at least we need to give time for people to digest some of those pieces. We're having issues with the IDE. We're having some build problems, etc. If we try to troubleshoot this is go for easily 3 hours, and we cannot have that time. But we can definitely have this in a second episode, and potentially even a third episode if we need to build this whole project. So what I would suggest is let's go back to the open source that the project has already been built. Walk us through very quickly where the code is. Very quickly, how does the register exam function looks like?
Sure.
And then we can recap on giving you all the tools that we actually use for today. And then the next episode that we can schedule, we can actually continue this, make sure that we don't have any build issues.
Yep.
And then we can go from there.
Okay. So so this is the final project structure. Looks a little bit like this. Okay. We've got all of our Lambda functions here that correlate to tasks that are implemented by our workflow. So the final state machine will end up looking something like this. So we've got all of our workflows. We can see here. Let me just zoom in a little bit. We've got all of our tasks mapped to a resource. We've got our schedule exam again mapped to another type task mapped to a Lambda function. And here we're doing some, and this is the student exceeds allowable retries.
That's what we're trying to define.
We want to, when that exception is being thrown, we want to capture that exception, right? So, and then we want to say, okay, if the error equals this exception, then I want to take, the next task is to take administrative action, right?
What I found cool about this approach, I'm not sure if you are following this right now, but the catch error equals to, the student exceeded allowable exam retries is, in fact, is really looking at the exception, the native exception that your programming language actually throws. Yeah. It is not something that we had to do exceptions dot or whatever. Yeah. In fact, it's the exception that you clearly defined in your code. So you're really mapping all your state machine business to business processes, and also mapping the catches and all the basic stuff exactly how your code really looks like. Yeah. So this for me is like amazing. Yeah. I mean, all of this try and catch, you definitely fail really fast on the Lambda, execute one thing as fast as you can, and let all of this orchestration logic being done by a separate provider. That's much better.
Absolutely.
Okay.
So if that exam scheduling of the exam succeeds, then the next step in the process is to send a notification. Here we're simply going to be executing a Lambda function that sends an email to the student, and then following that, we're going to have that wait condition that we talked about, right? Mm-hmm. So we've got our exam confirmation pending state, and we're going to set that to wait. Now here, rather than setting the number of seconds like we have done as we're kind of building this thing up, we're actually specifying a path, and this is a JSON path, to an object inside of our state, mm-hmm. and that is looking at at the first exam in the list. So when I'm creating, to make things easy, to make things easy, I'm always going to be adding the latest exam to the top of the list, so I can just simply always reference the first one in the list.
Interesting is that exactly how we started the whole stream. We wanted to include a timestamp and wait that could last a week or something.
Exactly.
But instead of actually defining the way you did in the console, a 10 seconds wait, we can do that dynamically.
Absolutely.
That's amazing. Okay.
Yep.
And by the way, it has to be a valid date time string in there, right?
Absolutely.
Okay.
So the specification that we showed you earlier details the specific date format that Step Functions expects to see.
Amazing. And where is all the code inside that particular GitHub
So
project?
I'm just going to zoom out here for a sec. So all of this stuff here is in the AWS Step Functions Plagiarism demo folder. That's where you got your all of the stuff. So the register incident stuff is in here. The schedule exam task that we were just working on, that's in here as well.
Yeah.
Now, and that's what this looks like. This is what we started building out.
Gotcha.
And then the final step, which we didn't get to complete here, was to insert that new exam into the exams list.
Gotcha.
All right?
And that's why you would return that particular
And that's all
array.
there is.
Okay.
Now, in real life, this is an example of how you would execute the workflow.
Mm-hmm.
In real life, you might be calling another system, right? You might be calling a system that lives on premises or in the cloud, or might be a SaaS provider that helps you with this stuff. Either way, this is really just to demonstrate the concepts.
Absolutely. Okay. Okay, Steve, so final recommendations. What would you recommend for people who are beginning with step functions or even .NET development? I know we talked about already the open source that you just done, all the open source bootstrapping project for .NET. You already talked about Visual Studio extensions for them to use.
Yeah.
And you also use step functions. If I were to do this locally, because I know the event are going to pass to state machine, would you recommend to just use some local invoke this particular event, and you can test your functions inside Rider or inside Visual Studio?
Yeah, absolutely. So what you can do, like some of the tooling in Visual Studio actually allows you to do that, exactly that. So unfortunately, we haven't been able to show that to you today, but what you can do once you've got the extensions installed, you can actually just right-click your project and then go deploy Lambda function. And the integration with the tooling and your account will allow you then to execute each of those Lambda functions individually direct out of the IDE. Now, if you don't have Visual Studio, then yeah, absolutely, you can use you can use the SAM CLI to do exactly that. You can use the AWS CLI to do that as well. The great thing about SAM CLI, it actually supports local development. So you don't actually necessarily have to be connected to an AWS account. You can do some local development right on your box, which is really fantastic for quick prototyping, development work, to test all of that stuff. So we do have support. So some of the when you're starting off. So a tip when you're starting off and you're building .NET Core applications on a Macintosh. There's some really great IDEs for that. Rider's really good. Visual Studio Code is excellent. Whenever you're developing in those environments, there is a dependency on mono. So in order
I had that issue before.
In order to do debugging and those kinds of things, you need to have mono installed. So just be aware that installing .NET Core SDK and framework isn't going to be enough to actually get you started on a development experience. Mono is also required.
Perfect.
But once you've got that, I think you're pretty much good to go. Like I've been developing on AWS for a long time, and I really find that building .NET applications on AWS is super easy. I'm not drawing any dependencies on the actual platform unless I want to start interacting with some of the services that I'm building solutions with. So yeah, it's fantastic to. Super easy to get started.
Amazing. So I sent all the links already to the chat for all the videos for build on servers, previous episodes for all the other languages. We already had a lot of languages in place. We had already Java, we had Python, now we're having .NET. We had JavaScript as well. There's Go coming up very shortly. This is it for .NET for now. We don't stop right here. We actually still need to build this entire project. So we're gonna be scheduling L in there. We'll be scheduling the next episodes to finish this up, and also writing tasks. One of the feedbacks now is I would love to see you writing tests for those particular functions.
Yeah, cool.
As well.
Yeah, and that's the next part of the this whole project, and this is an open source project. I'm happy to take pull requests and all the rest of it. So actually help me make this a better project.
Amazing. So thank you very much for actually helping us build all of this. Thank you for helping finding us the typos, those little nasty bugs as well. Hope you learned something, and all the links are there. If you want to know more about this and previous episodes and also upcoming episodes, go to aws.amazon.com/Twitch. You'll be able to find something called Build on Serverless. This is the series that we are building live coding on a monthly basis, and we're trying to build everything from scratch, from test, from CI/CD, from pipeline, everything else. Steve, thank you so much.
Heitor, thank you, mate. Thank you.
Nice. Anyway, so thanks for that, mate.
No dramas.
No dramas. Thanks very much, everyone. Have a great day. Thank you.
See you later.